In this video, we're going to look at another example of partial fraction decomposition. In this case, we will have repeated linear factors in the denominator. F of x is equal to p of x divided by q of x. Let's assume that q of x is a product of repeated linear factors. Furthermore, we will assume as usual that the degree of p of x, the numerator, is less than the degree of the denominator, q of x. And of course, we assume that p of x and q of x don't share any common factors. Let's assume that the first linear factor is repeated r1 times. Then we'll repeat all the way up to the power r1 times. So the first term will be a1 divided by a1x plus b1 plus a2 divided by a1x plus b1 squared. The third term will be a3 divided by a1x plus b1 cubed. And it goes all the way up to ar1 divided by a1x plus b1 to the power of r1. So we collect all the way up to the power r1. All right, let's look at the partial fraction decomposition of the following rational functions. In the first example, we have 1 over x squared times x plus 3. X squared is a repeated linear factor, is repeated twice. So we get a over x plus b over x squared plus c over x plus 3. X plus 3 is a distinct linear factor, it's not repeated, so we just get c over x plus 3. Let's look at the second example. It's a little bit more complicated. We have 2x plus 3 divided by x minus 1 squared times x plus 2 cubed times 2x minus 1 times x plus 1. The first factor is a repeated factor, that's x minus 1 squared, repeated twice. The second factor, x plus 2 cubed, that's repeated 3 times. The third and the fourth are distinct linear factors. We will do that like usual. So let's do the decomposition. We'll get a over x minus 1 plus b over x minus 1 squared plus c over x plus 2 plus d over x plus 2 squared plus e over x plus 2 cubed. So we repeat all the way up to the power 3. And the last two are just linear factors, so we get f over 2x minus 1 plus g over x plus 1. So the key concept is to repeat all the way up to the highest power of repeated factor. All right, let's do an integral of a rational function. Here we have integral x squared plus 5x plus 2 divided by x squared plus 2x cubed integrated with respect to x. The degree of the numerator is 2 because the leading term is x squared and the power is 2. The denominator, the leading term is 2x cubed, so the highest power in the denominator is 3. The numerator has a lesser degree than denominator. The degree of numerator is less than degree of denominator, so we can do our partial fraction decomposition. We will first factorize the denominator. So in the denominator, we factorize the x squared, take x squared out, times 1 plus 2x. Now we have a repeated factor, x squared, and just a simple linear factor, 1 plus 2x. And numerator, we have x squared plus 5x plus 2. So the decomposition will be a over x plus b over x squared plus c over 1 plus 2x. All right, now let's clear out the fractions by multiplying both sides of the equation by x squared times 1 plus 2x. So when we do that, the left-hand side, we just get x squared plus 5x plus 2. On the right-hand side, we get a times x times 1 plus 2x plus b times 1 plus 2x plus c times x squared. Now let's open this all up. We get ax. Actually, let's do it a bit more efficiently. So let's look at all the powers of x squared. We have 2ax squared plus cx squared. And now let's look at the powers of x. We get ax plus 2bx. And the only constant term is b times 1, that's just b. Now let's put all the powers together. Let's factorize x squared and factorize x. So we get x squared times 2a plus c plus, factoring x out from these terms, we get x times a plus 2b plus b. So you can see what our next step will be. The coefficient of x squared on the left-hand side is 1. We're going to equate that to coefficient of x squared on the right-hand side, which is 2a plus c. And similarly, the coefficient of x on the left-hand side is 5, and the coefficient of x on the right-hand side is a plus 2b. And the constant coefficient on the left-hand side is 2, and the constant coefficient on the right-hand side is b. All right, so let's look at all the powers of x squared, and what we get on the left-hand side, we get 1 is equal to 2a plus c. Equating powers of x on both sides, we get 5, because we have 5x here, is equal to a plus 2b. And looking at the constant term, that's 2 on the left-hand side, and the constant term on the right-hand side is b. Well, the good thing is b is already solved for. So let's plug b equals 2, plug in. Let's plug it into the second equation. 5 is equal to a plus 2b. What we get is 5 is equal to a plus 4, 2 times 2. Solving for a, we get a is equal to 5 minus 4 is 1. Now let's take a equals 1 and plug it into the first equation. So we plug in, 1 is equal to 2a plus c. So we get 1 is equal to 2 plus c. Solving for c, we get c is equal to 1 minus 2 is negative 1. So we now have a, b, and c solved for. We have b equals 2, we have a equals 1, and c is equal to minus 1. So let's do the partial fraction decomposition. We have a over x, that's going to be 1 over x. b over x squared, that's going to be 2 over x squared. And c over 2x plus 1, and we get negative 1 over 2x plus 1. So the partial fraction decomposition has been completed, and now we can integrate. All right, so we have integral x squared plus 5x plus 2 divided by x squared plus 2x cubed integrated with respect to x. We apply the partial fraction decomposition, and now we're going to integrate term by term. But before doing that, let's simplify the integrand a little bit. So we have integral 1 over x plus 2 x to the minus 2 minus 1 over 2x plus 1. All integrated with respect to x. The first integral, integral 1 over x, that's just going to be log of absolute value of x. The second integral, integral of 2x to the minus 2, reversing the power rule, we get 2 x to the minus 2 plus 1, that's negative 1, divided by minus 1. And the third integral, integral of 1 over 2x plus 1, that's just applying U substitution, and we will get log of 2x plus 1 divided by 2. Don't forget to divide by 2. What we're really doing is when we integrate 1 over 2x plus 1 dx, we're doing U substitution, we're letting u be equal to 2x plus 1, and du is equal to 2 dx. So we applied partial fraction decomposition to this integral, x squared plus 5x plus 2 divided by x squared plus 2x cubed dx, and we obtain log of absolute value of x minus 2 over x, simplifying the second term, minus 1/2 log of absolute value 2x plus 1 plus c. That is the answer. All right, thanks. I need to make a correction to this video. Due to a technical glitch, the numerator was faded out. So let's fix that. So here it is. The numerator should be 2x plus 3. That is the numerator. 2x plus 3. All right, thanks.